Hello, civil engineers. Welcome back to the lecture. So, in this project or in this assignment, this is a school building, okay? And I'll give you this. You have to do the assignment. So here again the same thing, okay? Everywhere the footing is given, like this is F1 footing over that C2 column, F1 footing C2 column. Then again you have F2 footing C3 column. In this way, all the footings has been given. Try to note down, and for that particular footing everything is mentioned in the schedule: f1 f2 f3 cf1 cf2 cf3 and so on. Okay, for combined footing cf1 cf2, the size is not mentioned here. For that you have to come here and see this is cf1, or let us say this is cf2. The size is given here in the AutoCAD. The breadth is 3250 and the this length is 6825. So based on that, try to make a note out of it and try to fill in your Excel sheet, and also if you want you can write it down. Okay, now the main problem is with this kind of footing. You see this footing, so this is a irregular shape footing. Okay, this is neither rectangular nor it is a square shape. Then how do you find the area of such footings? That I'll teach you here. Other than that, rest all things you have to do. And here the cross section is also given. In this you're supposed to find the excavation quantity, then you're supposed to find PCC, then footing shuttering, footing concreting, and the column concreting up to the neck column, and the shuttering quantity, okay, and the backfilling quantity. Again, this is your natural ground level. From here you are supposed to do 1.5 meter of the excavation, and one thing is that this excavation is still the PCC bottom is given, so directly you can take 1.5. Okay, and now when you try to find this neck column height, that is from here, this is your neck column height from here to here. So how we are supposed to do that? Again, we have understood that this 1.5 meter minus, this time you have to add the PCC depth also, because in the previous problems and all, what used to happen? We used to take the height from natural ground level to the top of the PCC, right? So directly this height minus the depth we were doing. But here, this 1.5 meter is shown till the bottom of the PCC. Okay, so that is why 1.5 minus 1.5 meter, yeah, 1.5 meter minus 100 minus the depth of the foundation. If you do, you will get this particular height. That is from this particular height you are going to get. Now this particular height is the depth of your plinth beam. It is already mentioned the depth of your plinth beam is 600 mm in all the cases. So directly take 600 mm from here. You're getting my point? So try to do this calculation. You're going to get. So I can explain you for one footing. Let us say this is one footing whose depth is 300 mm. Okay. Now you tell me what will be the height of your column. First, what you're supposed to do: 1500 minus the PCC thickness. The PCC thickness is 100 mm minus the depth of the foundation. Let us say for F1 it is 300 mm. Okay, so now if I get the answer, I'll reach to this level, plus I need to go till the plinth beam top. This is plinth beam top plus 600 plus 600. So if you do this, 1500 minus 300 minus 100 plus 600, I'll get 1.7 meter or 1700 mm. So this is your height of your neck column. For one add-on, you do it for all other things. Okay, so you'll get hands-on practice on this. Similarly, this is a cross section for the combined footing. Nothing changes, everything remains the same. Try to do the same thing, no problem. Okay, yeah. Now after that, now again rest things you have to note down. And on F1 footing, how many columns are coming? Like this is F1 footing, C1 column is here, F1 footing, C1 column. Again you see for F1 footing how many, yeah, here you see on F1 footing C2 column is there, F1 footing C2, F1 footing C2, again F1 footing C1. Means you'll write C1 column on F1 footing, how many numbers are there? Again again you'll write C2 column on F1 footing. Okay, so try to do this so that you get an idea. Now I'll explain you how this particular footing area has to be taken care of. Okay, this particular footing, it's a irregular. Now for the same thing, I've kept the footing here. So this is that footing. So one best thing what you can do in AutoCAD is you have to just select this footing, and there's a command called list. I'll do that. I'll write it here first. The command is list. Okay, so what you'll do, you'll select this and write list and hit the enter button. So the moment you do that, you will get the area of that particular footing. The area is 45.882 and the perimeter is 35.694. So directly you'll get the answer. But I'll teach you how it has to be done manually also. will match the value. Okay. If you're using AutoCAD, directly you'll get the area. You don't have to do calculation. But I'll teach you how it has to be done. Now, this is irregular shape. I'll try to convert this shape into either a square or a rectangular part. So what I'll do, I'll take a line command from here. Let me try to make this as one part. Okay, so this part and this part. So now this got converted into square and square. Then again, here you have small portion, this portion. This portion I'll convert again from here to here. This is another portion. Okay, converted. So this is also rectangle portion, square portion. This is a kind of a trapezoid. So you can directly keep a trapezoid and apply the trapezoidal formula. That also can be done. Else I'll convert this into a this part. That is a rectangle part. This I'll convert into a rectangle. Sorry, not a rectangle. I'll convert this into triangle. Wait. Yeah. So this is done. And similarly, this also I'll convert. Done. Got it? So in this way, I have done everything. Now what I'm supposed to do? I'm supposed to find the length of all these things. Already we have done that. So you see, everywhere I've done the length, but again, I'll do it. So I'll go here. I'll take this length command. You can see this dimension option. Click on the dimension and now select it. Dimension. And from here to here, check the dimension. 3275. Then again check from there here to here. So it is 3250. Then again, I want dimension from here 3250. This dimension already I know. I want this particular dimension 525. Okay. Then again, I want this particular dimension from here to here. You can take complete also, but if I get this also, it's okay. I can add and I can get it. Then I require this dimension from here to here. I think, yeah, small mistake I've done. See, this should be joined here. Okay. This should be joined from here. Yeah, now it's okay. And same thing here also. Here it is joined correctly. So this dimension and from there to here. Yeah, fine. Okay. So all dimensions I got. Now I want to find this dimension, no? This slant portion I want. So for that, again, I'll try to take this dimension from here to here, 1575. And this dimension I'll take. Yeah, it is 2475. Okay, fine. So next what we're supposed to do? Now I want this dimension from here to here. This dimension I'll bring. I'll select here. Then I'll click on this so that I can go angle. So it is 2394, 2934, 2934. So I think this dimension, yeah, fine. So let me verify this. How will you verify this? It's a simple thing. If I want to find this particular length, I need to apply the Pythagoras theorem where this square 1575 square plus 2475 square under root if I do, I'll get this answer. Quickly I'll do that. I'll give a name to that. Say let us say this is A, this is B, and this is C. Okay. So we'll write I want AC AC will be square root of AB square, AB square, AB square I'll write in this way, okay? AB square plus BC square, BC square, okay? BC square, done. So now come, under root, that is square root. What is your AB? AB is 1575, 1.575, 575 whole square I need to do. I'll write this thing, square I'll write in this way, okay? Plus again 2.475 whole square, okay? So try to do it manually and let me know how much answer you're getting. So under root of 1.575 whole square plus 2.475 whole square. So I'm getting 2.933. Yeah. So I'm getting this answer, I'm getting 2.9336 I'm getting, which can be written as how much? Which can be written as 2.934. And you can see the AutoCAD has given the same answer. That is 2934 in mm, 2.934 is in meter. Okay. You can make use of this AutoCAD and directly get it. If you don't have AutoCAD, try to do the manual calculation, apply the Pythagoras theorem, you'll get the answer. Right? Done. So once we get this, I'll delete it. Now directly, let me find the area of this. How will find the area? See, this is a rectangular, I mean, this is square. I'll just have to take the length and breadth. This is also square, this length and breadth. Then this is your rectangle portion, the length and breadth. This is your rectangular portion, length and breadth. And this is your triangular portion, half into length into breadth. Again, this is also half into length into breadth. If you do that, you'll get the answer. Okay. So here, this length I haven't found. Let me find that length also. Okay. Yeah, 975 and 2475, this, yeah, 2660. So try to do this also, whether, and let me know whether you are getting 0.975 whole square plus 2.475 whole square. Yeah, 2.660 I'm getting, same thing I got. Okay, fine. Now quickly let me add all these values now. So this area you find, this area I want. So how will you find? Quickly try to write it. That is 3.25 multiply by 3.275. This is the answer what I should get. 3.25 multiply by 3.275. So it is 10.64. Okay, this area is 10.64. Okay, now we'll be making a mistake. Okay. Okay, this I'll write it here. Okay. Yeah. Done. Next, we'll find this area now. So this area will be again 3275, and this is again 3. This is how much is this? Okay, I need to find the area. I hope you are able to understand. Okay. It's very simple, not an issue. Let me find this area again. No. Yeah, 3275 and 3250, same thing. So this I have to multiply by 2, because again 3250 into 3275, I'll get the same answer. So what I can do, I'll just multiply this, or I'll write this 10.64 again, 10.64. Okay, this part, fine. Next, we have to find this area. I'll find this rectangle area. So rectangle area is very simple. You have 525 here. This is 525, and you multiply this by this length. So this length is 3250 plus 2750 plus 3250. If you don't want to do that, directly take the values. That is also okay. So directly I'll keep it here, and from here I will keep it here. Okay, this I'll keep it here. 9250. This length is 9250. So write it here, 9.25 into 0.525. So how much you're getting? 9.25 into 0.525. So it is 4.85. Okay, this area is also done. Now we'll find this particular area. That is this area, and this. So that is, this is 6700 and this is 2475. Try to do that. 6.7, multiply that by 2.475. Let me know the answer. So 6.7 into 2.475. It is 16.58. Okay, 16.58. What, everything is meter? Okay, yeah. Now this triangular portion is left out. So this triangular portion and this triangular portion. Since triangle area is half into length into breadth, so we'll apply that formula. First, I'll do for this particular triangle. Okay, so half is 0.5. Half is 0.5. Half into length. So length you can take 2475. 2.475 into breadth. Breadth is 0.975. Okay, this is 0.975. So tell me the answer. 0.5 into 2.475 into 0.975. So you'll get 1.20 meter. Okay, this triangle is done. Next, I'll go with this particular triangle. So in this triangle, again, this is 1.575. This is 2475. So just try to do that. Again, half into zero point 0.5, half into length 1.575 into 2.475. So 0.5 into 2.475 into 1.575. So it is 1.94. 1.94 meter. Done. Now you add all the area. You should get that AutoCAD value what we have got. Okay. Now I'll add everything. So let me add everything. First I got 10.64. After that also I got 10.64. Okay. Then I got 4.85 plus 16.58 plus 1.20 plus 1.94. So try to do it and let me know how much answer you're getting. So it is 10.64 plus 10.64 plus 4.85 plus 16.58 plus 1.20 plus 1.94. So I'm getting 45.85. This is my area. Okay. And let me check what answer I'm getting in the AutoCAD. So what I'll do again, I'll click on this shape. First I need to select LIST. I need to write LIST. LIST. And you see how much I got? 45.882. I'm getting 45.85. Almost same. No problem. Okay. Now come to the perimeter. So what is this perimeter? Perimeter in the sense you have to add all the sides now. Okay. That is 3 to now all the sides in the sense, see, all the outer side you're supposed to add. Okay. This all the sides I'm supposed to add. So quickly let me do that. So I'll do that. How shall I do that? Very simple. I'll do it in my calculator. I won't write. So this is 3275. 3.275 plus this is 3275. No, this outer. Next, this is 525. 0.52. You have to just calculate the perimeter. Okay. Plus this is how much? 2.934. 2.934. 2.934 plus how much is this? This is 6.7. 6.7 plus how much is this? This was only outer part. Okay. 2.660. 2.660. Then again outer one. This part I want. This part is 3275. This is 3275. Okay. 3275 plus this is 3250. This is 3250. 3.250 plus this is 3275 plus this is 2750. Okay. Plus this portion. Finally, we have reached now. Okay, this portion. How much it is? 3275. And finally, the last one, because this we started from here. No, I reached now, and this one I need to add now. How much it is? 3250. 3250. So I'm getting 35.169 in my calculator. I'll write it here. I'm getting 35.169 meter. And let me check how much I should get. I mean, how much I got in my AutoCAD. LI, enter. 35.694. I got 169. Here I'm getting 35.694. So I think somewhere we have done a mistake. Somewhere there is a mistake. So I think we need to rectify that now. Yeah. That the mistake is I got it. See, the mistake was 2660. After that, directly I took 3275, isn't it? Directly I took 3275. But this portion I haven't added. That was some 975, I guess. Let me check. Yeah, 525. This portion I didn't add. 525. Now it will be correct. So I'll add it to this portion only. No problem. Yeah. Plus 0.525. Now I should get the right answer. 35.169 plus 0.525. Yeah, I'm getting 35.694. Now I'm getting 35.694. Let me verify the answer again. LI, enter. Yeah, you can see now. See, I got 35.694. Even in the AutoCAD, I'm getting 35.694. Done. So now you got the perimeter. Now with this perimeter, you'll find the shuttering quantity for this. How you'll find? You got the perimeter, multiply this by the depth of it. That is 35.694. Let us say this particular footing, it is CF1. Okay. And for CF1, what is the depth? It is mentioned in the table. For CF1, combined footing 1. Yeah, this is your CF1. See, this is CF1. Perimeter I got. The depth is 700. What you're supposed to do? Very simple. CF1 700. So I'll do that here. 35.694. You multiply this by the depth. Depth is 0.7. So if I do that, 24.98 square meter. So this much is my shuttering area. Okay, you're getting my point? This is my shuttering area for this particular footing. If you want to find the concrete quantity, how you will find the concrete quantity? Concrete quantity will be area. Okay, concrete quantity, that is volume of concrete for CF1. I'll write CF1. Okay, combined footing 1 will be how much area we had got initially? 45.85. 45.85 multiply by the depth of it. Depth, how much we got now? Footing depth was 0.7. That's it. You'll get the, what you're going to get? You're going to get the 45.85 into 0.7. 32.09 cubic meter. Okay. Yeah, cubic meter or meter cube or cubic meter. This is the volume of concrete that will go into this particular footing. Okay. So that much big is this particular footing. Yeah, because it's quite big only, Yeah, I'll clear everything. So because let me check the footing. Yeah, it's quite big only because 3.8 meter, then this meter, area is quite big. So area multiply by depth I've done. I got the concrete quantity for CF1. In the same way, you have to do it for this footing also. This footing, you try it on your own. Okay. And rest all things I've told you how it has to be done. So try to finish this assignment so that we'll have a good confidence in these subjects, so that when you work anyway, you'll not face any problem after this. So we'll see you back in the next lecture. Thank you.